All right, so welcome to the Intro to Python class. I am Erik Gross. That's me. And I am your host and instructor and in general nerd for the night. So I am a senior level software developer. I've been programming computers since I was around 11 years old, but been doing it professionally for decades and worked in technology ever since I got out of high school. So when I got out of high school, I went in the Navy. I was a nuclear reactor operator and electronics technician. Funny story about that. I grew up in the middle of the woods in Northern California, the son of hippies, and surrounded by people for whom the military was not a good thing. So when I announced in my senior year of high school that I was going into the Navy, my friends were teasing me that here's how they tease me. So I went into the Navy on December 7th, right after I graduated from high school. And my friends were trying to figure out what was the biggest disaster in American history: Pearl Harbor or Erik joining the Navy. That's how my friends are. Loved that. I am also the co-founder of the Tech Academy. We are, the organization is hosting these classes, and you'll learn more about that throughout the night. And I just love delivering these things. I love helping people bridge that gap between themselves and really truly understanding technology. Whether they go into it as a career or not, we're surrounded by technology. So anything that we can do to help make technology easy to understand, easy to use is a good thing. All right, so we do have a couple class rules to go over. They're pretty basic. We have an assistant, Regina. Those of you who have come to a few of our classes know Regina. She's awesome. She's behind the scenes all the time, monitoring the chat, answering questions, and she'll be there for you. She just said hi. Please be nice to everyone in the class. Regina will remove you if you're not nice, but I really don't expect that. I want to point out that these coding classes we do, they will be challenging. Now, don't get me wrong. Part of what we're trying to illustrate here is our teaching approach. And our students will tell you at the Tech Academy, while the curriculum and the material you have to go through and the exercises you have to do, while they're challenging, they are broken down in such a way that you can understand them and you can do them and you can gain mastery over the subject. But one of the aspects of learning about coding is finding out that while you're trying to figure out how to make your code work, sometimes it's challenging. So just be ready for that, right? It's part of the learning process. One thing you can do to make that go a little better is to write the code exactly. In other words, be sure you type code exactly as I write it. A misspelled word, a missing symbol, or even something capitalized that shouldn't be capitalized can actually result in errors in your code. And we'll go over that. We'll go over why. All right, good. So I've already gotten a bunch of communication going in the chat, where people are from. If you have never been to one of my classes before, please post in chat, say hi and where you're joining us from. If you haven't already said hi and where you're joining us from, and you've never been to one of our classes, I'd love to hear from you. Awesome. Shaylee is from, I hope I said that right, is from Maryland. More from Texas. Matthew's there. Excellent. Sydney. Oh, yeah. Love it. Excellent, Shaylee. Will's here from Alabama. I'm not far from there. Georgia, Yakima, Washington. Excellent. And Marcia's joining us from Florida. Portland, my home for 30 years. All right, we have people from all over. This is fantastic. I'm glad to see you all there. Excellent, Nitu. Glad to see you here. Okay, good. So be sure to use the chat, especially when it comes to we'll have a point in here where we have Q&A, which we'll go over in a moment. And the chat's there for you, and it is being watched all the time by Regina. So we'll try to capture everything that happens. All right, basic agenda. There'll be a short explanation of the Tech Academy, and then we're going to write some code. You're going to get your hands dirty, which is fun. When we're done with that, we'll have a brief Q&A session, and we'll go over some information about our boot camps. That's what we do, is we train people and help them break into technology. We have a free gift for you at the end of the class. Please stick around until then. The class usually takes about an hour, hour and a half. All righty. So who are we? Who is this organization that you've joined that's giving these free classes? We deliver coding boot camps. Coding boot camps are intensive technology certification programs. They're designed to prepare people for entry-level positions. They typically last 3 to 6 months, and they focus on practical, modern skills, the skills that get you hired. We've got 10 years of experience. We've been offering budget-friendly, thorough, flexible, trusted coding boot camps actually for over a decade. In fact, a week from now, we are having our 10-year anniversary online. You'll get links to that actually as part of our, we'll share a bunch of links with you at the end of this. But if you want to join our 10-year anniversary online, it's going to be a blast. Our certification programs, they're cost-effective and they're self-paced online coding boot camps. They're tailored for beginners, people who have no prior technical or coding knowledge, which is fantastic. So the last thing is that our certification programs, let me move this. Sorry, I just saw another question come up in the chat, but I think Regina's all over that. I just want to point out that the programs we have, they cover in-demand skills, like I said, and they're endorsed by stellar online reviews. And this is really key. They are designed to fit around your personal schedule. And they're designed to prepare you for your technology career with a well-rounded toolkit. In terms of price, the average price in America for boot camps is around $13,500. Ours are under the national average, and we even have programs that start as low as $5,300. Finally, I want to read our mission statement. And this says everything about who we are. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. All right, so before we code, let me cover a couple of quick definitions. They're very basic. A program is just this, written instructions that you can enter into a computer and then make it perform certain tasks. That's all a program is. It makes you in charge of the computer. Instead of consuming someone else's programs, you get to create the programs that people will use. You do this right in what's called a programming language. This is a system of words, phrases, symbols, and they allow you to communicate with the computer and tell it what to do. Programming languages are used to create these programs. And then there's the verb coding. This is the action of actually entering those instructions in. When you're writing out these words, symbols, and phrases, you are coding. The instructions you're writing, we refer to those as code. And finally, Python. Python is a very popular computer language. It's been around for, well, what is this, about 33, 34 years, maybe longer. It's created by a Dutch computer programmer named Guido van Rossum. He worked at Google for a long time, great guy. My co-founder, Jack, had the opportunity to interview him a while ago, which is really awesome. Python's awesome in that it's pretty easy to learn, and the language resembles common English words, and it can be used for almost anything, creating applications, websites, games. It's a very versatile language. So you can learn the fundamentals of that tonight. Now, before the class started, someone was asking basically like, what's the value? What am I going to get out of this class? And I'm going to be very blunt. What we teach on this slide is actually the most important thing we teach the entire night. Yes, you're going to code. You're going to get your hands dirty, like figuring out, how to write code and find out whether you like it. But the fact is, the 5 things on this slide are the most important things to know in the entire class. And it's because of this. Every computer program, no matter what language you write it in, no matter what the purpose of the program, every program makes use of these 5 elements that we're going to cover. Maybe not in this exact order, but you will find these things in every computer program and only these things. And so it's very helpful to know them. The first thing is an entrance. Every program, which is a set of instructions, has to have a place to start. When you double click on that icon for a program on your computer and say, please start Microsoft Word or start this video game or whatever, the computer is going to go, okay, so I'm about to start a series of instructions. What's the first one? Where do I start? So every program has an entrance point. The very first thing it starts to do. This is valuable because if you can start to look at your program, look at a program that you're going to work on right at the very beginning of it, then you follow through with the logic and you can start to understand the program much more easily. The next thing that every computer program has is variables. Variables are ways to keep track of data inside your program where the data can change. Think of, say, the number of students enrolled in a class, or the number of cars that came off an assembly line in a specific month. These are things that can change as the computer program is running. And so the program has to have a mechanism for keeping track of data that can change. Those are called variables. Another vital element of a computer program is what we call control or branching. There's a mechanism to make decisions. You have to have some way inside the computer programming language that you can make your program check a certain condition and have two or more options it can follow based on that decision. The options we call branches. There's different branches of the program that you can follow based on whether something's true or false. Like, if the number of students in a class exceeds 30, then spin up another version of the class and allocate a teacher to it. If it's less than 30, don't spin up another class. This type of decision. And all of these can be inside your program. I think you can see that if a computer program doesn't have this, it's not a very valuable program. We build programs to automate things that we can do manually. We make decisions all the time as human beings. The next element of any computer program is what we call subprograms. You can think of these as programs within programs. In other words, if there's a set series of instructions you find yourself repeating over and over again throughout your program while you're writing it, well, it's really valuable to take that series of instructions and kind of package them up into what we call a subprogram. And you give it a name, subprogram number 2 or whatever. Now, you give them better names than that. You'll see that tonight. But you take this series of instructions and put them off in a little container called a subprogram. And then whenever you're writing your program and you need that series of instructions to happen, you just call on that subprogram to run. That's the verb we use, is call. You would call the subprogram and its instructions would run. And then when they were done, you come back to where you left off. Very, very, very valuable. And it's part of every single computer program you'll see. And finally, every computer program needs an exit point. We need some way to tell the computer that this program is running on. We need some way to tell the computer, hey, this program's done. It's over. It's not needed anymore. It's not doing anything anymore. Why is this important? Well, there's a lot of reasons, but the big picture is this. While your computer program is running, the computer underneath is doing a lot of work to help your computer program. It's allowing your computer program, for example, to have access to the files and folders that are on the computer. It might be allowing your computer program to have access to the internet. It might be allowing your computer program to have access to some devices attached to the computer, like printers, keyboards, this type of thing. And your computer, the computer itself, is busy helping to manage your program being able to work with all those things. So the moment your program's done, we want to be able to tell the computer, hey, that computer program is done. You don't need to do any of that work anymore. And it frees up your computer to work on other things. So these 5 elements are present in any computer program. Again, they're not present in this exact order. It's just these are the things that we use to make up a computer program. And there aren't any other things. You can look at the most complex computer program, and in that computer program, you will only ever find represented these 5 elements. So that's why it makes it really valuable to know this. All right, so we're going to write code. We're going to do so in a code editor. Now, let me explain what a code editor is. It's a place where you can write these instructions, and then you can tell the computer to do the instructions. So you get to write out some code, and then it's called running the code. You give those instructions to the computer, and it does what you told it to. Good. Now, if you look inside of chat, you'll see that Regina dropped a link to the code editor we're going to use. I'm going to stop sharing for a moment, and we're going to switch to that just because I want you to be able to see it. All right. Share my screen again. this is what it's going to look like when you click there. Now, to explain, on the left is where you'll have a bunch of code. We're not going to use all this, but you can see this is code. Notice it reads almost like English. Almost like English. But these are computer instructions. On the right-hand side is where you'll see output. If your computer wants to print something to the screen, for example, this is where it will appear, is on the right-hand side. Now, the next thing I want you to do is this. Let's go back to the slide. And what I'd like you to do is set it up so that you have two things side by side. On the left, I would like you to have my video, the Zoom video. And the reason for that is I'm going to be sharing my own code editor. So on the left, I want you to have your Zoom program. And on the right, I want you to have that code editor that you just opened up. There's a few different ways you can do that. Sometimes on the Zoom part of it, you need to go to this restore button by clicking on the thing that says Zoom meeting, and the restore button will pop up. That lets you, change the size of the Zoom window. But I'll give a second here for people to adjust it. So on the left-hand side, you've got Zoom, and on the right-hand side, you've got the code editor you opened. Now, some people have two monitors. That makes things a lot easier. But if you don't, go ahead and have the video on the left in Zoom, on the code editor on the right. All righty. So now let's go ahead and write some code. All right. So we talked a lot about the idea that there's 5 different elements to any computer program. And so we're actually going to start learning Python by making those 5 elements. It's a real easy way to think with both those 5 elements and how does Python work? Well, first thing I want you to do, let me go ahead and change how big the font is here. I think I can go, there we go, nice and big, okay? Just delete everything in here because we're going to start all over. So we're going to write our first instruction. The first thing we're going to do is we're going to print something to the screen. So I want you to type print. That's the instruction in Python for printing something to the screen, print. Make sure it's lowercase. And then the way the print instruction works in Python, and this is true for a lot of languages, whatever you want to print, you put it inside of parentheses. The parentheses have to be immediately following the print word. You do not have a space. So I want you to do an open parentheses like that. This code editor will automatically create the closing parentheses for you, which is nice and friendly. Not all code editors do that. And anything you want to have print on the screen, you can put it inside of double quotes. So the double quotes are just to the left of the enter key. You'll have to do shift and then hit that double quote. And notice the code editor made the matching double quote. Now, what do I mean by the matching double quote? It's a real important learning lesson here. Computers work on patterns. They have built into them certain patterns. Computer programming languages work on patterns. When it comes to representing text, like alphabetical characters like A, B, C, D, and the numbers 0 through 9, when it comes to representing text, the way your computer program knows that you are trying to work with text is it looks for a double quote, and then it moves forward until it finds another double quote. You have a matching double quote. To a computer programming language, everything inside of those double quotes is text that you're going to do something with. And so the pattern is standard. Now, what this means here is you can type whatever you want inside of those double quotes and it'll appear on the screen. Let's type hello world. Hello, comma, world. And even put an exclamation point if you're feeling all enthusiastic. When you're done with that, go to this run button up here and see what happens. You'll notice that over on the right-hand side, it printed this on the screen. You made that happen. Now, for some of you, that may be the very first time you've actually controlled the computer to this degree. I know it's not very complex, but don't minimize it. It's actually pretty cool. So let's add on to this. Let's do another instruction where we're going to make use of the variable, because we've already got a first instruction. In Python, the first instruction usually is the one at the very top of the file. And here's our file on the left. This file is called main.py. That means the file name is main. Py means it's a Python file. So we know what we have our first instruction. It's right here. Now, let's have another instruction, but we're going to start to use variables. Remember, a variable is data that can change as the computer program is running. So I'm going to show you something kind of cool here. What I'm going to show you is the actual computer program that you'll ultimately be looking at, and you'll even get a copy of at the end of the day. It's a text adventure. And I'm going to run it. Let me change my font size here so y'all can see everything nice and big. Here's a bunch of instructions. Don't try to copy these. I'm just showing you what the code is. You'll get a copy of all this code. But this right here is a text adventure game. You see a bunch of code in here. By the end of the class, you'll actually understand a lot of what's going on inside here. But let's run this. I have just been alerted that I made a horrible mistake. I was supposed to teach you Hangman tonight. I apologize. Give me just a second and switch. We'll give you the code to this if you want. It's kind of fun. This is a choose your own adventure game. You can see it gives you options for what you're going to do. You put in your option, and based on it, there's a number of different things that can happen for you. I apologize. We'll get you Hangman. Just a second. Okay, here we go. Switch this out, and I'll share my screen again, and we'll be good to go. Okay. I hope you're familiar with the game Hangman. Hangman is pretty straightforward. You're trying to guess a word. And you can see here that it's asking you to guess a letter. And if you guess a letter, I'm going to go with, let's say, R. Ooh, R is not in the word. So now it's drawn a head hanging from the noose. Let's see. Give me an S. Oh, no. S is not in the word. Okay. Give me a T. Oh, man. I'm failing. I've got an arm on there. And then an E. E is not the word. Oh, wow. I'm doing horribly. How about an O? Nope. I'm about to die. Here we go. And we'll go N. Hey. Oh, okay. All right. I got one. Anyway, I'm not going to take you through the whole thing. But this is the game Hangman, right? And this is what we'll go through in detail at the end of the night. But you're going to understand exactly all the elements of it because that's what we're going to teach. All right, give me a moment here, and I will go back to the code. All right, so we need to create a variable here, right? Well, one of the variables we can have is, well, what's the name of the person playing the game? That would be easy enough. So let's create a variable in Python. And remember, this is data that can change as the computer program is running. Well, what if your computer program supports multiple players? You want to keep track of who the current player is. So we'll have a variable that is called player. this is how you make a variable. Just type the name of the variable. Python makes it very, very easy, which is really cool, right? So type player. And I want to explain what's happened. I know it seems super simple, but what's happened in the computer is this. The language Python is controlling your computer. And in this specific instance, what it's doing is it's saying, hey, computer, you have devices inside you that can keep track of information. The best way to think of these is almost like little buckets, like there's millions of little buckets inside the computer, and each one you can drop some information into. I want you to choose one of those buckets, and I want you to give that bucket a name. There's no data in the bucket yet, but give it a name. We're going to give it the name player. And honestly, I know that sounds rather simplistic, but it's not far from the truth. The fact is that the devices inside your computer can keep track of data, and they do operate very much like a bucket. And you do assign a name to each location in the computer that's capable of storing data. So we have a location called player. Now, that's all we've done. There's no information in the bucket. In other words, this variable, which is the bucket, the variable has no value yet. There's no data in the bucket. So now we need to give it the value. What data are we going to put in the bucket? In Python, you do that by giving a space. You can see there's a space on the screen here. And then you do an equals sign. Now, I said earlier that programming languages are collections of words and symbols. This symbol has a very precise meaning. And the meaning is this. Take whatever data is to the right of this symbol and assign that data to the variable on the left of this symbol. That's what this symbol of equals means. So we are going to put in double quotes our names because that's the value we want. So do a double quote. It'll have a matching one for you, automatically generated. Type your name. I'll type my name, but you type yours. Now, at this point, we've done two things on one line. We have created the variable called player. That's called declaring a variable. That's the terminology we use in the technology industry. We've declared the variable player. And then on the opposite side of the equal sign, we have given a value to that variable. That's called assigning a value to the variable. So we've declared a variable and we've assigned it a value. Fine. Why is this helpful? Well, because we now can use that variable in different places in our program. Let's do one here where we're going to print something using that variable. Do print, P-R-I-N-T, and instead of typing some text inside of double quotes, we can just use this variable player, P-L-A-Y-E-R. And what happens here when you run the program is that immediately after we've created this variable called player and given it a text value, in my case, the text value is the letters E-R-I-K, we're now going to use that variable. And here's specifically what occurs. The computer will see the command print, and it will look inside the parentheses for what it's supposed to print on the screen. Now, there's two types of things that can be in there. Things that are actually inside of double quotes, or or variables where the value of the variable is text. And we have a variable here called player with a value that is in fact text. So run this, and you'll see the first instruction gets executed, performed, run. That's all, by the way, those three words all mean the same thing. You can perform an instruction, you can run the instruction, you can execute the instruction. They all mean the same thing. It means give the instruction to the computer and make it do it. And then you can see nothing gets output here on this instruction because we're just creating the variable. But now we've used that variable. So what if a new user logs in? hit enter again. Let's change the variable to someone else. We'll change it to Joe. Do player space equals double quotes Joe. Player equals Joe. Now let's print the player again. print in parentheses, use that variable player. When you run this, you'll see Joe gets printed out. We have successfully created a way of keeping track of data that can change as the computer program runs. There's lots of things this it can apply to. If you've got a computer program that keeps track of inventory for a business, you could have a variable representing how many items of a specific product you have in inventory. That can certainly change throughout the day as we sell things and as we get new shipments in. It's another example, okay? All right, so that's variables. Great. Let's look at the next thing. Let me pull up chat. Lee has a great point. Seems like a good idea for a variable name to actually be descriptive of what is in the variable bucket. You're 1,000% right. And one of the things that you see sometimes in poorly made curriculum is that they would make a variable that would just be called, say, P. And that works. That will work, but it's really hard to understand what it means. That was a great point. Love that. All right. Give me a second here. Lee, you're awesome. Okay, good. So the next thing we're going to cover here is what are called control and branching statements. Now, again, the basic concept is this. Any computer programming language needs to give you a mechanism for having the computer make a decision. If this, then that kind of a decision. So I'm going to show you the way this is done in Python. Many languages have a very similar construct. So let's say that we need to be able to figure out whether or not the maximum number of guesses have been exceeded. We're playing Hangman. They're only allowed, say, 8 guesses. And we need to find out, have they exceeded the maximum number of guesses? Well, first, we need to know what the maximum number of guesses is. So we can have a variable for that. So let's have a variable called max guesses. So let's type max and then capitalize the G, UESS, max guess. That's our variable. What do we want to set it for? I think we're going to set it for 10. Let's give people 10 times, 10 tries to guess the word. So give a space. We've declared the variable max guess. Let's hit equals, and now we can assign it a value. Give it 10. Max guesses is 10. Good, fine. Well, we now need to build logic in our program for, again, what do you do if we are or are not exceeding the number of guesses? I think that's a pretty important thing to do. The way you do this in Python is using a command or an instruction called if. So type if. The way this works in Python is that you're about to check a condition. You're going to check whether or not something is true. And based on whether or not it's true, you're going to have 2 or more possible options that'll happen. So we need to put in the condition that we're going to check. Something that very clearly is or is not true. Well, we need to find out whether or not the number of guesses the person has taken is greater than the maximum. I think we need another variable, don't we? We certainly need a way to keep track of how many guesses has the person taken. All right, well, let's make another variable. Go back right under max guess. And let's decide a variable for that. I think this would be player guesses. You think so? That'd be pretty good. The player has a certain number of guesses. How many, or attempts. I'm sorry. The better word would be attempts. How many attempts have they made? So we'll type player attempts. That's our variable. And this is something that will change every single time they try a letter. Let's say it starts out at 1. They've tried 1. So the max guess is 10. They've only tried it 1 time. All right, that makes sense. So let's build our logic. What do we do if they've exceeded the maximum attempts? Again, go to the end of if and give yourself some parentheses, because inside these parentheses, we're going to put the condition we're going to check. We're going to check whether or not something is true. And the specific thing we're going to check is the number of attempts the player has made greater than the maximum number of guesses. So we can use the variables. We're keeping track of this data. It can change. So type in the variable that represents how many guesses they've, or how many attempts they've made. That is, and you got to type this exactly, player attempts, P-L-A-Y-E-R, capitalize the A, just like we did above, T-T-E-M-P-T-S. So we've got the first variable. Now, we want to know, is it greater than the max guess? There is a symbol inside of Python, and this symbol is the same in virtually every computer programming language, and it's taken directly from math. And that symbol is the greater than symbol. So give a space and hit the greater than. You'll find it near the shift key, usually above the period. So you hit shift, and you'll get that greater than. And now, I have 2 spaces there. We want to compare whether or not player attempts is greater than the maximum number of guesses. So you can type the variable max guess, M-A-X-G-U-E-S-S. Now this part is critical for understanding computer programming. Everything inside the parentheses must be capable of being either true or false, and that's it. Computers do not handle ambiguity. So when you are building these control statements and the different branches of what to do based on the control statement, you'll get used to designing conditions that we're going to check. The condition we're checking is specifically, is the value of the player attempts variable greater than the value of the max guess variable? Now, right now, we know it isn't, because player attempts has a value of 1. Well, it would if I hadn't gotten a typo right here and missed my equal sign. Player attempts has a value of 1, and max guess has a value of 10. So here's a special word. What the computer does when you give it this condition is it evaluates the condition. That's the exact terminology. It evaluates it. In other words, it figures out whether or not it's true. It's a pretty simple comparison. You're comparing 2 different numbers, but that's the verb. That's the process we go through. We're going to evaluate the condition. In this case, when we evaluate it, the result of the evaluation is false. So what do we do now? Well, we said we have this control and branching feature of any program. Well, we've got a control option right here. We're checking this if, we're checking this condition. So we can control, but we haven't got anywhere to send the program. We don't have any branches. So here's how it works. Go to the end of the sentence and hit a colon. In Python, what the colon means is, hey, listen, there's something special that happened right before the colon. And that something special means that some number of special instructions are going to happen. Those special instructions in Python have an interesting format to them. they need to be indented 2 spaces. I'll show you what I mean. When you hit enter, notice how the cursor automatically goes 2 spaces over. You can count them. 1, 2, right there. That's 2 spaces. You can do, there you go. It's 2 spaces. Why? It's one of the things about Python that makes it actually pretty easy to learn. If you have a small series of instructions that need to be run based on what is on the line above them, just indent them by 2 spaces, and it makes it really clear what the computer is going to do. Now, all this will become a little more clear as we write out the code. What I want to do right now is we need to figure out what are we going to do if this condition is true. Well, if it's true, they have another guess, don't they? So let's just, for now, to keep it simple, we'll just print something on the screen. If player attempts is not greater than the max guesses, if it isn't, then let's print something on the screen that says, you may try again. So let's type print, and then you hit your open parentheses. It'll create the second one for you. And we're going to put some text on the screen. So give me double quotes and type, you can make another attempt. You can make another attempt. So that's fine. We have one thing that we've provided for. We've provided for what the computer is supposed to do if I got it wrong. Player attempts greater than. No, you may not. So type not in there. We provided for what to do if, in fact, the number of attempts is greater than the max guesses. If they tried to make 11 or 12 guesses, this is not going to work. We're going to say, sorry, you cannot make another attempt. But now we need to account for what to do if, in fact, we haven't reached that point. And here's how that works in Python. A second. Hit enter. Go back over there. Hit enter. Now, this part is really important because when you're trying to learn Python, getting this next thing wrong can make your life very hard. We are creating branches of code. And what I mean specifically is we're saying if one thing is true, if the condition is true, do one thing. Otherwise, do the other thing. Well, what we have so far is if the condition is true, we wrote out what to do. We wrote out, we're going to print that you can't make another attempt. The next thing we need to do is put the other option. What if it's false? But if we start writing where the cursor is right now to Python, that means we are adding on to what to do if this is true. We do not want to type right here where the cursor is. Instead, you want to go back to the beginning on the same level as this if statement. And that's where we start creating the second branch. And you do that with a Python command called else. So type ELSE and do a colon after it. Why a colon? Because we're about to give an instruction or series of instructions that will only happen based on this else condition. So when you hit enter, notice that this code editor is nice and friendly to you, and it automatically moves you over 2 spaces. Really cool. So we're about to write instructions on what exactly to do if this condition right here is false. So what are we going to do? Well, if this is false, that means they have not actually made enough attempts. They've got more attempts. So we're going to give them the option to keep on playing. So let's print, print, open parentheses, and we can put in double quotes what we're going to print, 3 double quotes, and type, you can make another attempt. All right. So I think we have enough code here that we can kind of test whether or not this is working right. When we run this program, this is a fun thing. All right, now I'm going to ask a very precise question, so pay attention if you will. And don't answer right away. You got to think about this. I'd like you to put into chat the exact output that you're going to see over on the right-hand screen when I run this. What are the exact things that are going to print out? Go ahead and put that in chat. Take your time on it. Okay, I've got various guesses here. This is good. And here's the thing. I've gotten a lot of answers that say you can make another attempt. You're mostly right. Mostly. But there's actually a really important computer programming lesson here. Let's look and see the exact thing that's going to be printed out. So the exact thing that printed out is, hello world, Eric, Joe, you can make another attempt. Now, some of you may be angry at me right now, and I totally understand why. Because you did answer the question. Many people put in that what it would print is, you can make another attempt. But I asked a precise question. Tell me everything that's going to print out. What's going to print out on the other side? The reason I tell you this is when you start entering the realm of computer programming, asking the right question is critical. And the focus you have at any one point in time, because we've been focused right on this block of code right here that is highlighted. When you are focused in on one area, it's real easy to lose sight of the whole rest of the program. So that's why I asked that question that way. This is the exact thing that gets printed out is, hello world, Eric, Joe, you can make another attempt. Now, in place of Eric will be your name, but you know what I mean. All right, so I noticed I didn't see anybody that thought it would say you cannot make another attempt. And the reason why is that player attempts is not greater than max guess. Well, let's make it that way. Let's make player attempts 11. Now run it. And it says you cannot make another attempt. All right, so I just want everybody to step back for a second and just look at this code. And I want you to see that it's pretty easy to understand. It reads like English. And that's one of the nice things about Python is it's relatively easy to follow along with the logic of what's going on. But I want to illustrate something, even though it looks like English. It doesn't obey all the rules. Let's go in here and make this P capitalized. And then run your code. And we get some kind of weird old error, don't we? Now, you and I, in looking at the code we have on the left, we know what it's like English. Oh, it's supposed to print hello world. And then it's supposed to, make something that's equal to Eric and then print it. I can follow what's going on. Why shouldn't the computer be able to figure out, and this is a critical thing, should the computer be able to figure out what I meant? I mean, I meant to print it. Just because I didn't capitalize it, why does the computer care? Well, this goes back to the fact that a computer operates on different patterns. When you make a computer programming language, you lay out patterns of letters. In this case, the pattern happens to be lowercase p, lowercase r, lowercase I, lowercase n, lowercase t. That exact pattern, and only that pattern, is understood by the computer programming language Python to mean make something display on the screen. And the important thing to know is, even though to you and I it looks almost the same or even the same, that is not the exact pattern that the language was expecting. Why am I being all nerdy about this? Because understanding that all a computer program is often looking for is just repeated patterns can help you understand what the code is doing, and it can help you figure out what you're doing wrong when you're writing code. It always comes back to exact patterns. What was the pattern that was expected versus what was actually delivered? And here the pattern is lower cases. And we didn't give it lower cases. All right, good. Now, let's get into the last thing. This is kind of fun. I love this. So we've covered what's the first instruction. We've covered variables. We've covered control and branching. But now we need to talk about subprograms. So let me ask you a question. Let's say we did, in fact, give someone 10 attempts to guess the word. Well, every single time the person makes a guess, we would have to run this code again. Can you see that? They make their first guess. We've got to run this code, these 4 lines. They make another guess. We've got to run these 4 lines of code over and over again. We need to keep checking after every single attempt that the player makes. We need to figure out whether or not they've exceeded the maximum number. Well, this is where subprograms come in. We call them programs within programs. And I was a little more precise. I said, if there's a set of instructions that you find yourself needing over and over again throughout your program, pull them into a little teeny container called a subprogram, and then just use that subprogram whenever you need that series of instructions to happen. So we're going to make a subprogram out of these 4 lines of instruction. In Python, go ahead and go down a couple times and make sure you backspace so you're at the beginning of the line. In Python, with these subprograms, we call them functions. And in fact, in a lot of computer programming languages, the concept of subprogram, they use the word function for it. It's not the only word they use. Sometimes they use method. Sometimes they use subroutine. Sometimes they actually just call them subprograms. It's all the same concept. So remember, we are trying to make a named set of instructions. It's got a name, it's identified, that we can call on over and over again whenever we need it. So in Python, the way you do that is you define the function using an instruction def. It means define. And then you hit a space, and then you give the name for this set of instructions that you're about to create. The next thing you say is the name. This is the name of the function. What are we going to do here? We're going to check if they've exceeded the maximum number. So I would call it CHECK, check, done. Check if they're done. Are they done? Now, that's a name. Fine. Here's another super important thing. If you're going to create one of these subprograms, these sets of instructions that can be called upon as needed, there's 2 things to think about. One is, do you need to give the subprogram any information to work with? And the other one is, when the subprogram is done doing its job, is it going to give any information back to you? The term we use for that in programming is this. The things that you might need to give to a subprogram, we call them parameters. And the thing that the subprogram might give back to you when it's done doing its job, We call that a return, like as a noun. We call it the return. Whatever information is given back when the subprogram is done is called a return. So here, let's think. Is there any information that this function we're about to create, because that's what we call subprograms in Python, we call them functions. Is there any information this function is going to need in order to do its job? Well, this function is going to over and over again check to see whether or not the number of attempts has exceeded the maximum guesses they get. So it's certainly going to need those two pieces of information. The way you do that in Python is immediately after the name of the function you're creating, in this case, we call it check done. Immediately after the name of the function, we put some open and close parentheses. And inside there is where we put these parameters, the information we're going to give it. So we're going to give it two pieces of information. The first one is the player attempts. So make sure you spell this variable the exact same way. Do a comma and then a space, because you can give multiple pieces of data as parameters, and you just separate them with a comma. What's the second parameter we want to give it? The second piece of data that this function is going to need? It needs to know what the maximum guess is. So maxguess. And now we've made it so whenever we do in fact call on this function to do its job, it's going to be given some information. Now go to the very end after the parentheses and hit colon. Now again, what does this colon do? Well, it tells Python, listen, immediately following this colon on the next line or lines is going to be a series of instructions that are indented by two spaces. Those instructions down below this that are indented, this is what you're supposed to do when this function starts to run. So if you hit enter, notice that the code editor is nice and friendly. It automatically indents you two spaces. And every instruction you put after this, as long as it's indented two spaces, it will be part of this function. It'll be part of that set of instructions that will only happen when we call on this function to do its job. Well, what are we going to do? Well, it's the same thing we've been doing before. We're going to check to see whether or not the player attempts is greater than max guess. So you know what to write here. Type your if statement, put some open parentheses, and then put in the condition. Is player attempts space greater than max guess? End your parentheses. We've written our condition. What do you do after you're writing a condition? You put a colon. And again, the indenting is everything. Notice when you hit enter, now you're indented over 4 spaces. Why? It's the same thing. Underneath the if, whatever instructions are indented 2 spaces, that's what's going to run if the condition is true. We did this above, so we know what this looks like. So what are we going to do? Well, we're going to print, you cannot make another attempt. And that's all we're going to do. But now we need the else. Now, again, when you're learning Python, messing this next thing up leads to all sorts of weird errors. We're done creating the first branch of our if statement. We need another branch where we use the else command, but we have to put the cursor in the right place. So go back 2 spaces. You can just hit the backspace key. It'll do it for you. This is where we put the else statement. E-L-S-E. If we put else just underneath the print, it would think it was still part of the top condition. So we've got an else. This is a branching statement, so you need to put a colon after it. Hit enter. And again, the editor does nice, friendly things for you and indents two spaces. And now we're entering the instructions on what to do if the condition is false. Well, we know what to do. We wrote it above. Print, colon, you can make another attempt. And that's all we have inside our function. We don't need it to do anything else. So if you hit enter, make sure you backspace twice so that you're no longer on there. And now comes a really critical thing. And this, again, will help you a lot as you learn to code and as you analyze other computer programs. And even as you analyze the one, the full code of this game we're going to look at in a few minutes here. What we made on lines 19 through 23, this function we made is only potential work that can be done. When you make this thing called a function, because again, the concept of subprograms, when we use them in Python, we call them functions. This function, when we made it, is a description of what would be done if we ever asked for the function to be performed. But you have to ask for it to be performed. Watch this. Pay really close attention. I don't want you to delete the wrong thing. But this first if and else, I'd like everybody to delete it. And clean up the space in between. Check your code, make sure it looks like mine. And now I'm going to ask again. I'd like you to put in the chat what the exact output is that you expect to see when we run this. What exact output will we see? Assume you got it right first. Oh, I think Cade did. There we go. Hello world, and then your name, and then Joe. And that's all we're going to see. Good job. You guys are awesome. Let's run it. And there it is. Hello world, and then your name, and then Joe. So why didn't we get this, that you can't make another attempt? After all, player attempts is greater than max guess. And Sumi nailed it. The check done function isn't performed because we didn't call on it. Well, how do you call on it? In Python, all you do is type the name of the function that you want to have happen, give it its information, and that's it. So let's type the name of the function. It's, make sure you spell it the exact same way, capital C, H-E-C-K, capital D-O-N-E, do a parentheses, and let's give it the information it needs. We'll give it player attempts. Make sure you spell it exactly the way the variable is spelled up here. And let's give it the max guess variable. And now we'll run it. And if you did it right, you should get this output now. But check this out. Go down even farther in your code. Let's say that the player attempts is at 2. Type the name of the variable, player attempts. Of course, you might want to spell it correctly, unlike what I did. And let's change it to the value of 2. And this is the last thing we're going to do. Call the function again. Call check done by typing out the name of the function and pass in the same variables. Run it. And we get that they can make another attempt. Can you see how valuable it is to just have this one line of code instead of these 4 lines of code, especially since we're certainly going to do a lot more than just print something on the screen in the real game. All right. So those are the 5 elements of a computer program shown. Now, The one I didn't show is the exit point. In Python, like many computer programs, once you've reached the end of a file, here's all the instructions in the file. If you've reached the end of the file and there's no other instructions from other files waiting to be completed, then the computer knows the whole program is done and it takes care of all those things for you. All right, so let's show you the next part of this. This is awesome. This is the code for the game I showed you earlier, and I want to point out a few things. Notice that we have variables. I'll show you one, go all the way down here. We're going to give you this code. Every time we see the equals sign, we're dealing with variables. Look at this. We've got a variable called guessed, and we made its value equal to true. We have a variable called word completion, and we made its value equal to this really interesting command here. You don't need to know what all of it means right now, but you can, in fact, identify every point we're working with variables. Then let's look at control statements. Well, we have an if right here. You can even kind of check here. Okay, well, we're guessing a letter, and it looks like we're checking the length of the guess. Okay, and we know that if things are indented, that's all inside the if. You could start to read this and reason through the logic based on what you've learned already. You know that you can have control and branching statements, and you know that they're probably going to make use of if and else. So you can start to read through this and figure out, what does the code mean? And we have subprograms. We have defined a subprogram called play, and it takes a parameter called word. That reads just like English. Whoever programmed this used intelligent names for the functions and for the variables. When we play, in order to play, we need a word that we're trying to guess. Okay, so again, big elements here. We have a function, see, because it says define. We have a function called choose word. We have a variable called words. That's equal to, well, it looks like it's a collection of words. Do you see how you can start to read through this and start to actually understand what it's going to do? And it looks like randomly we're going to pick one of the words. So when I run this function called choose word, it will choose at random one of these 5 words. Okay, cool. I've got another function here. It's called display hangman. You can figure out what that's all about. It's going to take a parameter of how many tries have they done. And look at this. It goes in reverse here. It's got drawing a hangman. So that's the code. And Regina just put the full code into the chat, so you can have that. You can run it right now. In fact, I'd like you to grab it and just run it for a minute inside here. Just overwrite everything you have, all the code you wrote, and paste in that full code and run it and play it for a minute. All right. And give it just a second for some people to actually get the code running. And then we'll go on to the next step. Okay. All right. So let's have a little bit of Q&A here. Let's see if there's anything here. Regina, do you see any cool questions here in the chat?
I see one that Matt just typed in. Could you please explain the import random?
Oh, you're awesome. Yeah, absolutely, I will. This is a cool thing. Great question. So here's what Matt's talking about is I have this whole thing in here about right at the very top. There's an instruction I didn't even explain. Okay, so when you're programming, one of the most useful things is that really bright programmers around the world have over time made a bunch of pre-made code that very often you can use for free. Sometimes you have to pay for it, but a lot of times it's free. When you make a bunch of pre-made code, you're usually making it so you built a bunch of functions. Remember, we just built functions that all do a bunch of work revolving around a certain area. You might have a collection of functions all around accessing files and folders on your computer. You might have a bunch of functions all based around having a web page communicate with other web pages. And check this out. You might have a bunch of pre-made code all revolving around the ability to select random numbers and items. And this is what we're dealing with here. There is an instruction in Python called import, and it means grab a set of pre-made code and use it in this program. That's what import means. It means reach out to another Python file, another file that contains a bunch of Python code, and pull it into this one so I can make use of it. In this case, the name of that collection of pre-made code is called random. That's all this is. Someone built this. In fact, it was built around 33 or 34 years ago. It's been around for a long time. It's one of the most common things you might use, as you can imagine. Having things happen at random is pretty valuable. It's also, by the way, really hard to have a computer do things at random, but that's a whole other subject. So that's what that is. Import into this Python file pre-made code that's in another file. All right, good. Next thing, because I see it in there. Every computer programming language has the capability to put content in your code files that actually is not instructions. They're called comments. And that's what this is right here, this hashtag or pound symbol. This line doesn't control the computer in any way, shape, or form. It's not a Python instruction. It's not, remember, it's not one of the 5 elements. Entrance point, variable, controlling branching statement, subprogram, or exit point. It's none of those. It's just a comment. It's there to help you to understand your code and anybody else that comes along in the future to understand your code. All right, so I think in terms of Q&A, that's what we have time for. So let's look at the next step here. All right, let's talk about the school. Please stick around for your free gift because it is a really, really good gift. It's actually very real. We're actually going to send it to you. I think you'll love it. So what are coding boot camps? What are these Tech Academy coding boot camps? Well, we have 12 online boot camps. They cover a wide range of technology subjects. You can see them on the screen here. These include artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. There's a lot here. In fact, we have more certification programs than any other coding boot camp on earth. Our boot camps are self-paced, but they also have instructor support, which is a really great combination. They're flexible. Students set their own schedule and they can enroll any day of the year. 365 days a year, you can enroll. Our content is well-rounded and it's very in-depth. And our boot camps are affordable. We're priced well under the national average. Our programs, this is important, they include both job placement training and job placement assistance. And most importantly, these programs are designed for absolute beginners. You don't have to have any existing technology knowledge or programming experience. You don't have to be a nerd going into this. Yeah, it helps because you'll understand a lot of my stupid jokes as you go through the curriculum, but you don't have to be a nerd to get through this at all. As long as you can read, write, and do basic math, you're going to be fine. So who are our programs for? Anyone looking for a better career. The tech industry is a great industry to work in. There's remote work opportunities, there's a great work-life balance, and it pays well. We consistently land on every major best coding bootcamp list out there. Many of these organizations have been ranking boot camps for a decade, and we're always ranked on these best coding bootcamp lists. Our average review rating across all of the major bootcamp review websites and big players like Facebook and Google is 4.8 out of 5 stars, and this is based on student and graduate feedback. We're super proud of that. So these are some questions I have for you. I know that not everyone in this class, maybe is destined for tech, but I just want to answer a couple of things about why would you even consider working in technology? One of the biggest ones is work-life balance. Yeah, you're going to work hard. You're solving really difficult, challenging, fun problems. It's not like it's the easy street, but you're also not working 60, 70, 80-hour weeks and working for insane bosses and, busting your tail doing a bunch of hard physical labor. And a lot of jobs now in technology are remote, and it's a job that can be done well remotely. All the collaboration you need, the communication you need can be done remotely. It's also a very creative industry. There's a lot of creativity involved. Even though the programs you have to create have to be very precisely formatted and all this nerdy stuff we talked about tonight, the problems you're solving are very human problems. And there's creative ways of solving them, and you get to work with other people to design that. And when you and a team have solved a really cool problem, there's a lot of pride in your work, personal pride, which is great. The final thing is technology is a stable industry. If you're paying attention at all, like over the last few decades, technology is here to stay. We've got a talent shortage in the industry. We have for a very long time. The industry pays really well. And as long as you keep learning and advancing and getting better at your job, there's regular increases in pay. It's not capped, which is really, really cool. It isn't all sunshine and roses, though. There are barriers to entry. Specifically, our methodology of doing a boot camp, accelerating your route into tech, getting it all done in a few months, there are barriers there, to be sure. One of them is that the tuition for a boot camp can cost thousands of dollars. We, however, have tried to solve that with a number of different things. We have several different financing options, including an upfront discount. If you just pay it all up front, there's a huge discount. We have monthly payment options. If you have no credit or bad credit that can be accommodated. There's a tuition option for everyone, no matter what your financial condition. But the fact is, doing a Tech Academy bootcamp is an investment in yourself. You are increasing your value in the marketplace because you are possessed of a skill that is not common and is highly needed by business organizations. Now, here's the other aspect, is time. There's definitely required time investment. You're going to be learning a lot of stuff, and you're going to have to learn it in a very truncated period. There's been various approaches to this. One of the more frustrating ones is a lot of boot camps run on what they call cohorts, where they batch everyone who applies together. You're not allowed to start yet, and they group them all together, and everybody starts on an exact day. So you might have to wait a few weeks before you can even start. And even then, when you start, everybody's moving through the material at the exact same pace. And I'm telling you, I don't know about you, but I don't learn at the same pace as everybody. Some things I do great in, and some things I just have to take some time to get through. Our programs accommodate that. And one of the worst things is some programs require you to be there in person, which means if you're not geographically near one, you're in trouble. So what do? Well, all of our programs are online and they're super effective. Yeah, if you live in Portland, Oregon, you can come into the campus, but we deliver these fully online and have been for years and years and years. It's a great online experience. Another really cool thing about the time factor, you choose your study schedule. Yeah, you have to put in a certain minimum number of hours so you can make sure you get through the program, but you decide when you're going to put those hours in. So you can do part-time study, and you can study concurrent to, holding down a job or going to school. The fact is, people have lives, but you can fit this in around it and make it work, which is really, really cool. The last thing is the factor of how much technical interest or ability do you have? This is very personal for me. Yeah, I'm a nerd, but at my heart, I'm an educator. I want to impart knowledge to people. And one of the things about this whole industry that's kind of challenging is a lot of the existing technology training materials are just frankly too hard. It isn't that the subject is too hard. Technology and computers is at its core quite simple, but the existing materials make it seem like it isn't. And the reason why is that a lot of educators assume too much prior knowledge on the part of the learner. So what do? Well, there's a lot I could tell you about how we've structured our curriculum to handle that. But the big picture is this. You don't have to be a nerd to get through our program. You don't have to have any technology background. We have built it so that we lay in the foundations well and build little bit of layer complexity by little bit of layer complexity to the point where, a few weeks into this, you'd be like, I cannot believe how much I've learned. It's really, really cool. So here's the question I have for you is, are you maybe working a dead-end job? Little personal satisfaction in what you're doing, or there's a ceiling income-wise that you're hitting and you know that you're capped? Maybe you're even unemployed. Or you're working a job where there's just no possibility of working from home. Either they will never allow it, or the nature of the job has to be done in person. Or maybe you want more time with your loved ones, more flexibility in terms of how you organize the different aspects of your life. The big question is this: is it time for a career change? Only you can answer that, but I recommend you look at it. And if it is, well, the Tech Academy is the solution. We are career change experts. The logo here is a bridge for a reason. We want a route into technology for everyone. And the bridge represents that path over that knowledge gap and into the technology world. And you can do that in a variety of roles. We've got 12 boot camps, but if you went into that world, we can bridge that gap. And it works. I mean, at this point, we have over a decade of experience making people into tech. Most Tech Academy graduates make $30 an hour on average in their first job. That's $60,000 a year. And at this point, we know it works. We've got over 1,000 graduates working in tech at all kinds of places, like small businesses, all the way up to, a lot of our people have been posted at big companies like Nike, Facebook, Disney, Uber, Epic Games. So it's a reminder. We have open enrollment, which means you can start anytime with a tremendously flexible schedule. So I encourage you to enroll now. How do you do that? Go to this link. Regina's going to drop it in the chat. There's a very simple sign-up form there. And what follows after that form, I don't want you to do all of it right now. Just, fill out the initial form. But what follows after that is a series of steps all about the Tech Academy. There's videos there, articles, and there's even an optional step to book a call with admissions. We want you to understand as much as you possibly can about the school and our methods to make a really informed decision. So fill it out now and complete those steps after the event. I'm going to wait for a moment for people to fill that out. And stick around because your free gift is about to pop up. Will's got a great question. I'm not going to dive into it right now, but Will, the exact way we approach that is answered within the first, I think, right after you fill out that form. The first video you see in there will answer that question in full. I'll give you all the background data. I'll give you a real off-the-cuff answer right now, but it wouldn't be doing it justice. And yes, there's lots of lecture, lots of video, but I want you to look at that that content right after the form. It'll answer it in full. I'll be frank, and then we'll move on. When Jack and I were designing how to do this back in like 2014, like how do you make a self-paced program that can accommodate people with different schedules, either full-time or part-time, and be really effective? Like that was a challenge of magnitude. And I'm going to be completely honest about it. I'm very proud of what we put together. We had an idea that would work, but now years and years and years down the line, you absolutely can get through it, even with a shifted around schedule. And when you're done, you really know it. You can apply it on the job, and you get hired, and they're happy to have you there. And you look around, you're like, oh my God, I did it. I'm in a technology job. It's tremendously gratifying. All right. So one thing that's really cool to know is this: our graduates love us, and because of that, referrals have for years been one of the top enrollment sources for us. So years ago, we put in place a referral program where we pay 5% commission for all enrollments if they come to the person who referred them. Well, that isn't just for our graduates, that's for anyone. So if you would like to refer someone to the school, we'll keep track of that, and we will in fact pay you a 5% commission payment if they enroll. It's that simple. So in a moment, you can have an opportunity to email into us to get your free gift. If there's someone we should be talking to, put their name and contact information in there. We'll keep track of that, and we will absolutely give you, the 5% referral commission. We love paying them out. It makes us very, very happy to do so. All right, now Tech Academy, we're getting up to the free gift here, so I want to give some context. Tech Academy has 7 publications at this point, including 3 Learn Coding Basics in Hours book. You can see those at the bottom. A coding book for kids and young adults, a technology basics dictionary, the project management handbook, and You Are Not Stupid. Now, a brief word about the book, You Are Not Stupid. We have, right at the beginning of all of our boot camps, a phenomenal course called the Computer Basics course. Handles all your mystery you'd ever have about any aspect of computers and technology. It's really, really cool. We took all that and put it into a book, and it added even more content. All the modern technology terms and concepts are defined, and we even added a history of technology that shows you how we arrived at the present day. It's I like to joke, and it's not a joke though. If you are gradually turning into the tech support person for all of your relatives, or you've got a friend or a relative who just can't understand technology, get them this book and make them read it. And I guarantee you, they're not going to call you as often with very absurd questions or how do I operate Facebook? They're going to understand technology. It's the whole point. It's really, really good. All right. So we've been talking about a free gift. This is a free gift, and it is a physical book that we want to send to you. Now, this is for students in the United States only. I'm sorry, we can't do overseas, okay? So in the US only. But if you're in the US and you would like a copy of this, all you got to do is just send us, this is super important. Every once in a while, someone forgets. Email in, include your name and your mailing address, because for real, we're actually going to send you this book. It's a nice book. You'll get it in the mail and be able to read it, right? But you have to give us your mailing address. So here's the other things you can put inside that email, though. If there's other questions we didn't get a chance to answer in this class and you've got some burning questions, drop them into that email. They get forwarded to me. I answer all those questions. And secondly, if there's anybody you want to refer to the school, include their names and contact info. Regina will keep track of all of that. And if they sign up, we'll be sending you a check for 5% of their tuition. So email here at books@learncodinganywhere.com. Yeah, pause for a moment so I can take a sip. Now people fill that out. All right, now I mentioned links. We've made this really easy. We use Linktree. If you're not familiar with it, just a nice little utility out on the web where you can list all of your links in one place. Makes it easy. So what will you find here? And by the way, Regina is going to drop that link into chat so you can all grab that, okay? So what's here is a bunch of things, but most importantly, we mentioned that we have free educational videos out on YouTube. The link to that playlist is at our link tree. Also on there, links to our books and our dictionary, links to our upcoming meetups, which means if you want to attend future classes like this, all the links are on there. Links to our social media accounts, it's all on there. So please follow us on social media. Please invite your friends to future classes like this. And this is a pretty cool one. If you'd like to get your own free copy of You Are Not Stupid, you've got an opportunity to win one. Every week, we have a bit of a lottery on this. And to enter into it, to have a chance to win it, we only ask one simple thing. Go to the links that we're giving you here and get the link to the next event we're having. Share that link on social media and tag the Tech Academy. Don't do it if you don't want to. It's totally fine. But if you like what you got here and you want to spread the word about it, share the link to the next event, tag the Tech Academy, and we'll drop your name in the hat to win your own copy of You Are Not Stupid. We give them out all the time. We love doing it, just for people being kind enough to share the word about who we are and what we're doing. All right. And that brings us to the end. If you have filled out this form, please follow the steps afterwards. They're very educational, very helpful, and you'll learn everything about who we are and what your route into technology is, all of our programs. And thank you for coming to this. We're very glad to do these. And I'd love to see you in our next event. We do 2 of these every week. Go to that link and you'll find all of them. So I'll sit tight for a minute and see if there's any other, important questions that come in. But other than that, you're awesome. Thank you and have a great night. Thanks, Ernst. Welcome, Marcia. Good to see you again, Lee. You're welcome, Shrub. Thanks, Michael. All right. Thank you all so much. Have a great night. Go Niners!